Alright, the third video in this course where we are converting Bruno Simon's portfolio project from three.js to React Fiber. In this video, we are going to go over the JavaScript folder. I'll explain the folder and file structure that Bruno used here. And once that's done, we're going to dive into the application.js file. This file contains a class application. We are going to convert this class into a React component. Now keep in mind that during development of this entire project, we want to be able to keep our project running, which means that we're going to have to keep a lot of the JavaScript code that's in here because we only convert this file yet. So other files will still be in plain JavaScript. Now, in the future, we're also going to convert other files to React components. And at that time, we might be able to reduce the amount of JavaScript code here and use more of React Fiber's capabilities. Alright, so let's get started with explaining the folder structure and the file structure of this project. And therefore, I'd like to start with the application.js where we are in right now, because this is the entry point of the project. And you can see that in the constructor, because here we are constructing some of the base code of this project that gets used in most of the other files, such as the time, sizes, and resources. Time is being used to run specific code on every frame, which can be used for animations, for example. Then we have the sizes, which is used to retrieve the size of our window or to handle resizing correctly. And we have resources, which is used to load all the textures and the 3D models inside of our scene. Now the resources file is right here, but the other two, the time and the sizes, are inside of the utils folder right here. And next to that, we are also calling some functions in the constructor, such as setConfig, which will set some global configuration for this project, such as if we're in debug mode or if we're running this project on a mobile phone. And I'll actually show how that looks. So if we go to the application, normally you'll just go to the normal website. But if you would add #debug, you might need to run this twice. Then you'll actually get to see a debug panel here provided by .gui. And here you can change some values, such as you can enable the orbit controls, which will allow you to look around, zoom out or in, or pan around. And there are a lot of different options that you can tweak here. We're gonna do this later on in this project as well, but we don't want to use .gui, but we're gonna use Leva here. And the next function that's being called here is the setDebug function, which adds the panel that we just saw in case we are running in debug mode. Then we have the setRenderer, which sets the WebGL renderer with the correct configuration, such as the right colors and so on. Then the setCamera, which will set the camera and make it move together with the car, because if you move around with your car, the camera will follow. That's all handled here. Then we have the setPasses, which will provide some post-processing logic there. We have the setWorld, which contains most of the 3D objects inside of this scene. It will load all the textures and show most of what you actually see on the website. Then we have the setTitle, which is a bit specific, but if you look on the top of our tab, you'll see that once I move around, the title actually moves along, and that's all handled there. And then we have the set3.js journey function, which sets some references to his own course, such as this notification that you see here. And if you click on this button, it will actually send you to the course. Okay, and next to this application.js, you have a lot of different files. I won't go into detail about every file as I did with this one, but you have the geometries folder, which contains some custom geometries that Bruno created himself. some custom materials in the materials folder. We have the passes, which are used for post-processing. The utils, where I already showed 2 of the util classes. And it also contains a loader, which is used by the resources file to load all the different textures and 3D models. And then we have the event emitter, which can be extended from another class to emit events, so that other classes can listen to those events and act on them. All right. And that's everything I'll mention about this project, or at least the JavaScript folder. We're gonna dive into every file specific later on, but this is giving some global context about all the JavaScript code. So now we can dive into converting this application to a React component. For that, I'm going to use a VS Code extension because we could do this all manually. That would work fine, but I'd like to spend less time on it by using the Glean VS Code extension, which makes refactoring a little bit easier in React. So one of the highlighted functionalities that they provide is they allow converting class components to functional components and vice versa. So yeah, install that one and then go back to your application.js. Let's copy this over so that we don't change the original file. And rename it to folio.tsx. So this is going to be a React component, and that's why it needs to have the extension tsx. And as soon as you open this file, you'll see that it's entirely filled with errors. Don't worry too much about that. By the end of this video, we will have fixed all of them. So yeah, let's dive into the first errors right here at the imports. It's mentioning that it cannot import, that it could not find a declaration file for this module. And that's correct. This is a TypeScript error because there are no types available for those kind of imports. And for now, that's actually what we want because we don't have types for all the different files yet. So what we're going to do is we go to the tsconfig file of our project. And in here, we're going to change allow.js to true. And that means you might need to wait a while. And that means that all imports with the .js extension, so all the JavaScript files will now be accepted. So there are no more errors related to that. We still receive an error for .GUI because that package is a JavaScript package. So there's a separate package called @types/.GUI, which includes all the TypeScript types for that package. So if we install that as a dev dependency, there we go. The error should be gone now. Alright, so let's convert this application to a React component using the Glean extension. But before we do so, the Glean extension can only convert a React class component to a functional component. So we're first gonna need to convert this to a React class component. And we can do so by extending the component class from React. So now it is a class component. But we will also need to change a few other things because, for example, we don't need a constructor in our functional component. We can just use the component dip mount function for this. This is going to give an error because it's not expecting any parameters. So we're gonna have to remove that. And in those parameters, we used to send the canvas. But we're gonna get this canvas from the React Tree Fiber context that we are in. So we're not gonna set it here anymore, but we're gonna retrieve it using the use3 hook later on. So for now, I'll remove that. And this wrong code. And then on the bottom, we have one more thing that we need to change. Because we currently don't have any render function which is needed for a React component. So what we're going to do is we're going to add a render function which just returns null right now, so that we can actually run the extension. And the way to do so is by selecting the entire class and then press Ctrl dot. Unfortunately, you'll also get a lot of other messages because we still have a lot of warnings and errors in our code. But there should be an option to convert your class to a function component. It will give you a warning. This then will be a problem in our case, so we can just continue. And there we go. So now it should be a functional component. Now this might scare you even more because now it's completely filled with errors, but those are easier to solve. First of all, we don't have to send any properties anymore, so let's remove that. And we need to import the use effect hook because somehow it didn't import that automatically. Then all the use callback functions are gonna show some errors because we didn't provide any depths, which is the dependency array. That's the second argument that we need to pass. We only want to run this code once, so let's add this array to the end of every use callback call. So it's there. Okay, so I added the empty dependency array to all the use callback functions. And the next thing we're gonna have to do is fix some issues of the Glean extension. It is not perfect, unfortunately. If you do have a better tool to convert a class to a React functional component, then please let me know. But for now, we're gonna fix this manually. So one of those issues is that it's still referencing this sometimes, even though passes is now a variable that's available in the root of our function. And it is a reference. So what we actually want instead of this is we want to call passes.current. Now, to do so, I created an regex, which I'm going to be using. So if you search in this file and you fill in that regex using the regex option and replace that with the actual variable name, so that will be passes in this case .current dot, and all the cases where this happened will be replaced, and it will look like this. This does raise another issue though, and that is that the current value can possibly be undefined. Now this is because TypeScript is not sure if those values are defined, and the Glean extension that we used only converts the class to a functional component in JavaScript, but it doesn't support TypeScript. So what we're gonna have to do is add the type to all the variables that Glean created for us. But we don't actually know the type of those values yet because they are still JavaScript files. So the way we're gonna do that is we're gonna add a generic to all the use ref calls that we do, and we're gonna set the type to any for now. And that will already greatly reduce the amount of errors that you'll see. Keep in mind, once again, we use this because everything else is still in JavaScript. We're going to convert everything class by class to TypeScript so that slowly we will not need to use those any keywords anymore, and we can actually use real types. And then there's one more error that the Glean extension didn't take into account very well, and that is that it still uses props on quite a few locations. I'm not sure why this is happening, because for example, if you would compare this code in the setConfig function, it starts with setting the config.current, just like it's setting the config here. But as soon as we want to access or set an actual property on that config, it starts to do that on the or set the property of the props variable now. Unfortunately, we'll have to fix that by hand. So there's still a little bit of work, but yeah, the extension already saved us quite a lot of time to convert this to a React component. I'll fast forward this because it's quite a bit of work, and I'll get back to you after. Okay, so now that's all done, you'll see that there are no more errors anymore in this file. There is still an unused variable though, that's the destructor. I'm not sure why it isn't used. It also wasn't used in the original code, so that might have been a small mistake. But we are going to add it to the use effect hook as a return value, and that will mean that it gets executed when the component gets unmounted. And that is all we had to do to convert this application to a functional component. But we will still need the WebGL renderer inside of this file. So the way we're going to get that is using the use3 hook. But we can only use that in a child component of the canvas component from React Tree Fiber. So to do so, we're gonna add a new file called foliocanvas.tsx, which is going to be a React functional component. We don't need this import anymore. And in here, we're going to return the canvas component from React Tree Fiber. And as a child, we will pass that folio component that we just created. Okay, so let's add folio and actually rename the application as well, because it's not application but folio now. And we'll have to export that at the bottom. Okay, so this means that now we have access to the use3 hook inside of our folio component. So if we go there, then on the top, let's add under all the references, let's get the renderer. It is called the GL property, but let's rename it to renderer and get that from the use3 hook. That's from React Tree Fiber as well. Okay, so right now we are redeclaring the renderer property. We don't need that one either anymore. So now we have the renderer available, which is of the type WebGL renderer, which is referenced multiple times in this project. But currently it's still trying to get the current value because it used to be a reference before. We don't need that anymore. We can just pass the renderer now. So let's remove that everywhere. And there we go. Save the file. And let's try to run it. Okay, I started running this code and it still seemed to completely work, which was unexpected. So I checked what it was, and we actually forgot to include the folio or the folio canvas component inside of our app, because currently we're still using the import to the index file. So let's now replace the content of the app function with our newly created folio canvas. And that means that we can also remove the 3 scene. So let's do so. And we don't need to import the folio index.js anymore. Let's also remove the other imports, and there we go. Now it's a lot cleaner. There is still one error that I forgot to fix. So if we go back to the folio component, you'll see here on line 80, it's trying to call the add function right here on scene.current, even though scene.current is not set. And the scene got set in the set renderer function that we had before, but we removed that one. But we still have access to the scene by using the use3 hook for that as well. So we can just get the scene there and remove the reference right here. This will cause the same issues as with the renderer. Now we got a scene of type scene instead of type that we get when we use the useRef hook. So that means that we'll have to remove the .current everywhere that we use it. There we go. Now if we save it and refresh the page, you'll see that the canvas is very weird. Now somehow it isn't using the entire width and height of the screen, even though I mentioned before that React Fiber would take care of this. And this is because in our app.tsx, we just import the folio canvas, which uses the full width and height of the parent component. Now the current width and height of the parent component is this size, but we actually want it to be the full size of the screen. So what we do is we wrap it in a div and give it a class called width screen and height screen. Those two classes are provided by Tailwind CSS, which is part of the base code project that we used in the beginning. I also installed a Tailwind CSS extension to make this work, or to give us additional information. So I'd recommend you to install that Tailwind extension as well, because for example, while we are typing those kind of classes, you get to see what those classes actually do. For example, the h-screen class will give this component a height of 100 view height. We're going to dive deeper into Tailwind CSS when we add support for some overlay regarding the mobile buttons for moving forward or backward, etc. But for now, this is all we need regarding Tailwind CSS. Now let's save this file. And there we go. This looks way better already. Let's see about the errors in the console. They should be gone as well. But there are still some issues. It's, for example, got a different color right now. And you can scroll to the bottom and horizontally as well. And we are going to look into that, but that will be in the next video, because this video is getting quite long and we still have some things to do. For now, I want you to be proud of what we achieved so far. We are using the canvas component now from React Fiber inside of Bruno's project. So that's already an achievement on its own. So yeah, next time we're going to look into those colors, the color differences and how to fix them. And I'll discuss some of the configuration options that we have on the canvas component there. So see you there.